Hello. Camera's over there, but I'm looking over here. I have another screen, so I'm gonna be facing like this. So let's watch first.
Let's watch.
Let's begin over here. All right, so this is the famous experiment that Draft Science uses as decisive evidence to support his model. But I have noticed a few things. So first of all, the reason why he thinks this is good evidence is because the bigger card comes out with half the velocity. So in his model, he says when a one mass collides into a two mass, the two mass can only come out with half the velocity at best. Because then all of the momentum would have been transferred to card two. So he thinks that, right? Yeah, so he thinks that this one is exactly twice as heavy because when we measure it, the bigger card seems to be twice as long as the smaller part. I have noticed it's not exactly twice as long. It's a little bit shorter. I mean, the smaller card is not exactly half as long as card two. It's a little bit shorter than that. I will show that later in the video. But first of all, so let's take a look at the timings. Let's assume for now that this card is twice as long as this one. So let's say it's 20 centimeters and this one is 10 centimeters long. And so we have these numbers. Okay. In this case, when it is exactly twice as long, then the velocity, the incoming velocity from part one is 282 meters per second. And then part two comes out with 0.140 meters per second. And that is almost exactly twice. So it's 2.014. It's pretty much exactly half the velocity. So it is true, yes, this second card comes out with half the velocity, exactly half the velocity. But notice, in Draft Science model, okay, so when card two, so card two has a momentum of 0.282. And then card one has an initial momentum of 282. And then after collision, card two comes out with 280. Okay, should I write it down? So the P initial equals 0.282, and then part two comes out with 0.280. So basically, oh man, that's small. So basically, part one has transferred pretty much all of its momentum to part two. And in Draft Science model, right, this means that part one is left with almost zero momentum, pretty much zero. And what it means is so part two has given all of its momentum to part one has given all of its momentum to part two. And so part one should remain stationary because it has no momentum left. If it has no momentum, it can't go anywhere. It should remain stationary. Now, does that happen in this experiment?
Let's watch.
Nope. Part one actually bounces back. Part one bounces back and it still has velocity, it still has momentum. But it has already given all of its momentum to part two. So it should remain stationary according to Draft Science model, but it still bounces back. It still has momentum. And so at the end of the video, we can see the timing of part one bouncing back over here, which is 0.17989. And that means that I've calculated the momentum of part one bouncing back is 0.05558. Okay, so when P1 prime equals 0.05558, right? And so P2 part two had a momentum of 0.280. Now, according to Draft Science, momentum is always positive, direction doesn't matter. So, which means that the total momentum of the system, the momentum of card two going in that direction, plus momentum of part 1 bouncing back. If you add those together, we have a total momentum of 335. But the initial momentum that went into the system was only 0.282. 0.282 went into the system and 0.335 came out of the system. So that's actually also a free momentum experiment. We have free momentum. Once again, if we take into account part 1 bouncing back, this is a free momentum experiment. That's the first thing. Then the size of the cards. So I took a print screen and I placed these lines on the edges. Okay. So now, when I copy this, let me put it over here, and I copy this. As you can see, perfectly on the edge. Okay. And I place this right under here. Okay. And then I double this one. Like that. Then we can see it's not exactly half as long. The card 2 is actually a little bit longer. You can see there's this area over here that is missing. Oh, come on. All right, this area is missing. This one should also be, well, you can see card 2 is a little bit longer. If we place two card 1s next to each other, then the edge comes to it. Then we have an edge over here. But card 2, the edge of card 2 is over here. So it's a little bit longer. It's this amount longer. Okay. And if we, so I'm gonna copy this one. Well, I have write down this. Hold on. This. So this part is actually missing. This part. If card 1 was this amount bigger, then it would have been exactly half as long as card 2. So, which means if card 2 is 2 kilograms, if card 2 has a mass of 2 kilograms, then card 1 has actually a mass which is a little bit less than 1 kilogram, because it is a little bit less long than half the distance of card 2. Now, over here, we can see these numbers on the ruler, and I've drawn some lines, and I've used this to create a ruler over here. Okay, this. And I've tried to measure it as best as I could. So card 1, I came to the conclusion that card 1 is actually around 18.7 centimeters or inches long. And card 1 has a length of 9.2 centimeters. 9.2 centimeters versus 18.7. So it is card 1 is a little bit less long than half the distance of card 2. And then I asked ChatGPT to calculate what the mass would have been, what the mass actually should be. And it gave me the answer of 841 kilograms. So instead of 1 kilogram, it should be around 841 grams, and which could be realistic. So actually, as you can see, this chunk is missing in order for it to be exactly half as long as card 2. And so if this total thing, including the missing chunk, equals to 1 kilogram, one might assume that, yes, this little chunk that is missing, in order for it to be 1 kilogram, has a mass of 159. So 159 grams is missing in order for it to be exactly half as long as card 2. So we can, so 1 kilogram minus 159 grams equals 841 grams. And so that could be realistic that that card 1 actually has a mass of 841 grams instead of 1 kilogram. Okay. So instead of it being a 1-to-2 mass ratio, 1 kilogram versus 2 kilogram, we actually have 841 grams versus 2 kilograms. Which is a 2.3 mass ratio. Instead of 1-to-2 mass, it's a 1-to-2.3 mass ratio. And then it perfectly matches with conventional science. My argument is that no, this is not a 1 kilogram versus 2 kilogram. It is around 840, 850 grams versus 2 kilograms. If we say that card 2 has a mass of 2 kilograms. So it's not a perfect 1-to-2 mass ratio. It's rather a 2.3 mass ratio, a 1-to-2.3 mass ratio. Right, that's enough, I think. Yeah, well, whatever. Debunked or not, doesn't really matter. But there you go. Those are my thoughts about this experiment and draft science claims. I'm gonna end the video now.